Hello everyone, hope you're all doing well, having a great time, and of course, staying safe. So, this is class 9 science lesson, chapter 12, and in this chapter, we will try to talk about heat. Let's start. Temperature. Do you know what is the temperature? If I asked you that question, you probably will answer me and say, well, it is hot or cold. Then I will tell you that that is not a scientific way, or that's not a scientific term. If you really want to specify how hot and cold something is, you must use temperature. So what is a temperature? A temperature is a measure of how hot or cold something is. Or you can say a measure of average kinetic energy of a particle in an object. You know what is a kinetic energy? It's the energy of motion. Something is moving, it has kinetic energy. So the particles of an object, when they are moving, the measure of that average energy, kinetic energy of a particle is called temperature. We are using temperature every day. Let's say that you are coming out from the roof in your own home. The roof is very sunny and very hot. You're going to the balcony where there is shades and there's a fan working. You probably think it is a cold place if you compare it to the roof, but your brother is coming out of the room that there was a air condition working in. So when he comes to the balcony, he actually feels very warm. So if we used a word cold and warm, it actually makes us confused. So to avoid this, we use temperature. So what is a temperature? Temperature is the measure of average kinetic energy of a particle in an object. Temperature and kinetic energy. There's a question. If you knew the answer to that question, you will probably get the whole idea behind temperature and kinetic energy. Before I ask you that question, you already know that all the things that around you is made of matter. What is matter made of? Matter is made of atom or molecules. These molecules are always moving. It doesn't matter if it's solid, liquid, or gas. It is moving. The rate of their motion are different, but they are still moving. Even if they do not look like they are moving, but they are moving. Because particles are in motion, they have kinetic energy. The faster the particles are moving, the more kinetic energy they have. So what is the relationship between temperature and kinetic energy? What is the link between them? And this is the question. If an object have a high temperature, that object have a high kinetic energy. So the more kinetic energy the particles of an object have, the higher the temperature of the object is. So what will happen if I measured a temperature of an object, any object? What you actually do is when you measure an object's temperature, you are measuring the average kinetic energy of all the particles in that object. Keep in your mind, the particles are moving at different speed. So any object in front of you, their tiny particles are moving at different speeds. Individual particles have different amount of kinetic energy. Once again, let me ask you, what is the relation between temperature and kinetic energy? Now, your answer should be the more kinetic energy a particle of an object have, the higher the temperature of that object. Let's talk about the picture in front of you. We have an ideal gas, and heat is added to one of them. Look at the particles of that gas. You can see them moving in all directions. So what happens when you add heat? This heat increases the kinetic energy of the gas atom. When the kinetic energy of an atom increase, their temperature also increase. So keep in your mind all the thing around you, solid, liquid, or gas, they are moving, their particles are moving, but they have different amount of kinetic energy. Each particle of those matters have different amount of kinetic energy, but their particles are moving. Average kinetic energy of particles. There's a very simple thing in this part I want you to understand and learn. If we had a pot of tea and a cup of tea, now what is the difference between them? The amount. The amount of tea in the cup is less if you compare it to the amount of tea in the pot. What about their temperature? This is the point. The temperature in the pot, the temperature of the tea in the pot, and the temperature of the tea in the cup are the same. How do I know? Well, you already know that temperature of a substance depends on their kinetic, the average kinetic energy of all its particles. So all the particles of the tea, actually, the average kinetic energy of all the particles of the tea tells you what is the temperature of the tea in the pot or in the cup, right? Yes. So the temperature does not depend on how much of it you have. It actually depends on the average kinetic energy of its particles. So their atoms have the same average kinetic energy. If you took an atom from the cup, from the cup of tea, or an atom from the pot of tea, they have the same amount of kinetic energy, average kinetic energy. So the pot of tea and a cup of tea are the same temperature. If I ask you, how do you know the temperature of your own room at home? Or if I told you, well, tell me the temperature of a bowl of soup in front of you, would you stick your finger in it? Or you will try to taste it and know the temperature with a spoon? That's wrong. The suitable tool to know the temperature of things around you is actually thermometer. To know a temperature of anything, you should use a thermometer. Now, we have different kind of thermometers. As you can see in front of you, some of the thermometers are basically they use mercury in it. Others, they use alcohol in it. Why they chose mercury and alcohol for thermometer? There's a reason behind it. Because they remain in liquid form over a large temperature range. Why thermometer can measure temperature? The answer of that question is because of the property called thermal expansion. Now we should ask, what is thermal expansion? Thermal expansion is the increase of volume of a substance because of an increase in temperature. I don't know if you have seen a thermometer before, but whenever you stick a thermometer in let's say a really hot pot of tea, if you carefully observe the substance in that thermometer, you will see how it actually raises. So why would this happen? So let me explain it in a very simple way. If the object is hot, the substance is inside the thermometer temperature increase. And you already know when something's temperature increase, their particles move faster and spread out. And if something spread out, they take more space. So there is more space between them. And the substance expands. That substance could be mercury or alcohol. You should also know that the amount of expansion for each one of these substances are the same at the same temperature. You can say that mercury and alcohol expand by the constant amount for a given change in a temperature. The picture in front of you tells you how different things have different temperature. This is first. And second, how we have different scales to read temperature or to know temperature. As you can see, we have Celsius, Fahrenheit, Kelvin as a scale. But notice how human in each one of them have the same level. So they are all at the same temperature. Different reading, but the same temperature. So alcohol in each thermometer has expand at the same amount. The reading are different. For example, human temperature, if you try to read it with Celsius, it would be 37, 36. While if you use a Fahrenheit, it will be 98.6. What about if I use Kelvin? Then my body will be 310 degree Kelvin. Remember, numbers for each thermometer is different because a different temperature scale is marked on each one. If you ever watch the weather report or the weather channel, you will hear the temperature given either in degrees Fahrenheit or degrees Celsius. Now F represent Fahrenheit and C represent Celsius. However, scientists usually use Celsius scale. In the Celsius scale, the temperature range between the freezing point and the boiling point of water is divided into 100 equal parts. Now we have the third scale, which is Kelvin scale, is divided into units called Kelvin, K, not degree Kelvin, only Kelvin. Now we have the lowest Kelvin scale, which is 0 Kelvin. What is the 0 K? It is absolute zero. So what is absolute zero? Absolute zero is a temperature at which molecular energy is at a minimum. 0 Kelvin on the Kelvin scale, or minus 273.16 degrees Celsius on the Celsius scale. So you can say in an absolute zero, or about minus 273 degrees Celsius, the temperature at which molecular motion, the motion of the molecules, stops. It is not possible to actually reach absolute zero, although temperatures very close to 0 Kelvin have been reached in laboratories. Temperature conversion. The table in front of you actually shows you how you can change temperature between different scales. So you can, for example, in the previous slide, you learned how water will freeze at 0 degrees Celsius, 273 degree Kelvin, and 32 degree Fahrenheit. So if I asked you 0 Celsius is equal to the 0 Kelvin, to answer this question, we should actually use the following equation. So we want to change 0 degree Celsius to 0 degree Kelvin. The equation that tells you how to convert Celsius to Kelvin is the following. Temperature in Kelvin equals temperature in Celsius, which is the 0. We will place 0 in that place, and plus 273. So your answer will be 273 degree Kelvin or Kelvin only. Only Kelvin, because it would be wrong to say degree Kelvin. Now I want to change 0 Kelvin to Celsius. The equation for this is the following. Temperature in Celsius equals temperature in Kelvin minus 273. So 0 minus 273 equals minus 273. Now you realize that the temperature 0 degree Celsius is much higher than 0 Kelvin. What if I told you there were 1 degree change, increase or decrease, on Kelvin scale and on Celsius scale? You will have to know that a change of 1 Kelvin is equal to change on 1 Celsius degree. 0 degree Celsius is higher than 0 degree Fahrenheit, but the change of 1 Fahrenheit degree is not equal to change of 1 Celsius degree. Obviously, you can use these rules or these equations in the table in front of you to change or convert between temperature units. So as you can see, you can easily change Celsius to Fahrenheit, or you can change Fahrenheit to Celsius, as the examples in front of you shows. Applications of thermal expansion. Now, thermal expansion has many other applications. These applications might be very useful. One of these applications are expansion joint on a highway. I'm pretty sure you heard the sound that car makes when the car goes over a small gap. These small gaps are called expansion joints, and they are usually found on bridges. These expansion joints are very useful because it actually prevents the bridge from breaking. How does this happen? Well, if the weather is very hot, the bridge can heat up. Well, when things heats up or their temperature increase, they expand. As it expands, there is a danger of bridge breaking. So, expansion joints keep segments of bridge apart so that they have room to expand without the bridge breaking. And this is the answer for the question in the self-check or the self-check question. The self-check question says, what is the purpose of expansion joint in a bridge? The expansion joint keeps the segments of bridge apart so that they have room to expand without the bridge breaking. Another application of thermal expansion is thermostats. Now, thermostat is a device that controls the heater in your home. We have a kind of thermostat that there's a strip inside of it. This strip is called bimetallic strip. Bimetallic strip is made of different metals in a thin strips. You know that different metals have different, they expand at different temperature, at different rate. Because different metals expand at different rate, one of the metal expand more than the other one when the strip gets hot. This makes the strips coil and uncoil in response to change in exactly temperature. What happens because of the coiling and uncoiling? Well, the electric circuit that controls the heater and makes the heater on and off is actually open and closed because of it. Let me repeat it one more time. First, we have a metallic strip that is made of different metals. Because different material expand at different rate, when the temperature increase, one metal expand more than the other. Then this makes the strip coil and uncoil. This coiling and uncoiling closes and opens an electric circuit that turns the heater on and off. Thermal expansion in hot air balloon. In this part of the lesson, we will try to look at the principle of hot air balloon, how it works. Or we can try to answer, why does hot air rise? So, as you can see in the picture, when a gas is heated, its particles have more kinetic energy, which means they move faster. They move around more quickly, so there's more space between them. The hot gas is then able to expand if it's not kept at the same volume by its container. What happens inside the balloon? Inside the hot air balloon, a mixture of gas inside a hot air balloon is heated. The air expands. As it expands, it becomes less dense than the air outside the balloon. So the balloon goes up, up. And we reached the end of this lesson. The section review in page 225 is your homework. Thank you for your time and thank you for your attention and good luck.